Hi, everyone, and welcome to Summer 2021, Midterm 2, Question 7a. This was a question about tries, or more specifically, the myTriSet class, which is an implementation of a string set using tries. It follows the standard design that we've seen in class. It has a root node. Each node has a flag or a Boolean variable saying whether or not it's the ending of a word, and it has a map mapping characters to nodes, to the next node. Okay, so in this problem, our goal was to implement the numPrefixesOf method, which takes in a string key and returns the number of words in the try that are prefixes of that given string. So for example, if we have a try that takes in if we have a try that contains beetle, bin, beetlebugs, and meals, then numPrefixesOf on beetlebug will return 3 because bee, and beetle are prefixes of beetlebug. It's also helpful to note that beetlebug is a prefix of beetlebug. Anyways, so when dealing with these kinds of problems, I always like to think about what is an algorithmic idea that I would actually use before I actually look at the skeleton code. I don't know, it's just helpful to have an idea of what you're doing before you actually start looking at stuff, right? Before you start looking at actual code. Okay, and a good way to come up with an algorithmic idea is to look at a diagram. So here's an illustration of the try set that we were given in the problem statement. Right, it has beetle, bin, beetlebugs, meals. By the way, here's the website I used to generate it in case you're curious. And okay, when dealing with any tries, what is the very natural thing that we do with tries? We traverse them, right, using some word. So if we're gonna, just out of curiosity, if we were to go ahead and traverse this try using beetlebug, the word that we were given in the numPrefixesOf, right? We go down B, E, hey, there's B, E, there's B, T, L, E, that's beetle, B-U-G. What we notice about this is if we traverse down for beetlebug, we encounter all three of the words that are prefixes of beetlebug. And that makes a lot of sense, right? If we're going to, basically go across each character beetlebug, we're going to run into all the prefixes. I mean, that's kind of the definition of a prefix, right? And so this actually gives us a very natural idea for what kind of algorithmic idea we can use, right? We traverse down the try for the given word, and we count the number of words that we encounter, or in other words, the number of green nodes or the number of word endings, like whatever you want to think of it as, right? Put it plainly, go down to try for the given word, count number of word ends, return that number. Now that we have an idea, let's go ahead and take a look at the skeleton code. Okay, I've taken the definition of the TriSet class just for reference. So let's go ahead and take a look at the method that we need to implement. Here is the starter code we were given. It has a nice little base case. Just make sure that if you get null, you return 0. Has it sets some variable count to 0, and we return that variable at the end. So that's what we need to modify or increase or whatever in order to make sure that our algorithm works correctly. And then we have some starter node that gets set up to the root. Okay, that's all the typical stuff. Then we have the for loop that's going to go across and iterate across each of the characters in the string, or it's going to iterate across the length of the string, right? But we're probably going to use that to get the characters in the string. And this should indicate to us that there's probably not going to be any recursion in this problem because, okay, we're kind of already going across each character in the string, so there's no need to recurse really because we kind of have everything we need to do the traversal. Okay, now let's just go through what's inside the for loop, which is the stuff we actually need to fill out. We're going to set up some character C. Who knows where we're going to set that up to? I mean, probably it's going to be the ith character and key, but let's not get ahead of ourselves. So we do that. We then ask, okay, or then we have some if statement that if that condition gets triggered, we're going to break. Just thinking about it logically, what is the top or a condition we can think of when traversing a try that if that condition is met, we should probably stop. It's if we find that there's actually not a new if we're at a node, right, and we need to we're at the ith character, we're at the ith node, and we find that there's actually no sort of path corresponding to that character, then we know we've hit a dead end, right? Like we've traversed as much as we can, but actually the rest of the path that we needed to take is not there. So we know we need to stop. That's probably what this condition is going to be. Then we have a nice, convenient little empty line that doesn't, like we can do whatever we want with this. Since it's the only such empty line, this is probably where we're going to update the current node, because we do need to do that every iteration if we're going to traverse the trie, and there's no other place to do it. So it's probably going to be here. And then we're going to have an if statement that allows us to do whatever we want. Logically, we do need a place where we're going to increment count, right, to do our algorithmic idea. So this is probably going to be the place. So this, this is where increment count, and this if statement body, or not the body, but the actual condition itself, is probably going to be if this current node is a key, or is the ending of a word. So now that we've kind of looked at the skeleton code and we think we know what each line is going to be, let's try and actually write it down. Okay. So character C, let's just, it probably is the ith character. Okay. This if statement, like we said, it's going to be, if basically the current node doesn't have any path for that character to take. So, we'd say, okay, does it contain this key? Does it contain a path for us to go? But, if it does, we want to continue. So we actually want to put a not here just to make sure that if we're asking it, okay, if there's no path, break. Yeah, this seems like a good idea, right, to update the current node. So let's go ahead and do that. cur.map.getZ, get the next node. And then let's do what we said we were going to do and make sure that, okay, if cure.isKey, then, we're going to go ahead and count, we're going to increment count by 1. Okay. Okay, let's go through this one more time and make sure that this all makes sense. We iterate across each basically character in the key. We say, okay, if there's no path for us to take with this character, we stop. There's nothing else for us to do. But otherwise, we get the next node and then we ask if it's a key. If it is, we increment count by 1 because we know we've found another prefix. Okay, one thing you might note is that we kind of skip the first node, right? We never ask the first cur node if it's a key because we went ahead and got the, but before we go ahead and ask if we go ask the question if cur.is key, we update cur. But that's fine, right? Because the first node is root. So that's actually a good thing. We don't want to ask if the root's an empty because the root doesn't store anything. And so there you have it. That's a working solution for question 7a. So I hope that was helpful. And yeah, thank you for watching. Goodbye now.